Preparing and assembling lithium-ion batteries presents with several key challenges. First of all, we have to make the best combination of materials to have an increased capacity and the best performance out of them. But apart from the materials, the assembly of its own holds several difficulties since it needs high precision and extremely controlled conditions with moisture-free environment. One small manufacturing defect in the assembling of the battery cell can cause not only poor performance but also lead to the total failure of the cell. When also trying to move to more upscaled levels of the manufacturing, there are many challenges also there, since the results that you initially got at small lab scales, they are not most of the times repeatable when you're moving to bigger quantities and qualities and upscaling the procedures. So in INERRANT activity, we have partners that they are taking great care in manufacturing anode, cathode, electrolyte and separator that will not only provide high quality component for our cells and high performance, but they are also specifically designing this component in order to be safe and sustainable. At the end of the activity, we are also going to have some recycling, which might also give some answers to the supply chain issues that we are dealing now in the battery manufacturing. Benchmarking process for the developed lithium-ion batteries is crucial for evaluating the performance of our developed cells, but also they provide very useful feedback for the design optimization, and also they give us insight on the customer needs, the market needs, and also the competitive landscape of these technologies. So in order to being able to benchmark our cells in INERRANT activity, it is important to identify industrial standard cells, leading commercial products, and also their testing procedures and how they are performing them. So standard procedures should be followed for the testings. Some key metrics that we have identified in order to set the performance standards include performance characteristics like capacity, energy density, power density, cycling stability through life cycle testing, and capacity retention, as well as impedance spectroscopy and equivalent series resistance measurements that will also provide very useful information. We always keep in mind the thermal stability of the cells and the safety characteristics, and we have in mind the cost of the material production, the processes and the material upscalability, as well as the sustainability of all the components, the processes we're using.